You are most welcome to our YouTube channel. Today we are going to look at finding valency of radicals. These are groups of atoms which cannot exist on their own. For example, we are having this radical 1. We are going to find its valency. Now, look at this. This is the hydroxide. This radical is called the hydroxide. You look at this atom here and this atom, you will find that if you are to have the structure of this atom, of this radical, where there is oxygen and the hydrogen. What is the electronic configuration of oxygen? It is 2, 2, 6. What is the electronic configuration of hydrogen? It is 1. Now, this oxygen gains electron. And when it is gaining, that means that it is going to gain this 1 electron. So this 1 electron has to come from the hydrogen. So when one electron comes to hydrogen, because this oxygen needs the 2 electrons, this oxygen gains the 2 electrons. Hydrogen has only 1 electron in its structure. So it is taking the 1 electron to oxygen, and still oxygen needs the 2 electrons. Therefore, there is a balance of 1 electron missing for this oxygen atom to be stable. And that 1 electron missing, it implies that even the oxygen, since it is gaining, the charge is negative. And then this radical will have a valency of 1. And its formula of the ion will be OH minus. The minus is on oxygen atom because it is the one which is gaining the electron from the hydrogen. Number 2 radical is carbonate. Carbonate has carbon and 3 atoms of oxygen. So we distribute them. We distribute this atom in a structure of carbonate so that you can have this. And what is the electronic configuration of carbon? Is 2, 2, 4. Electronic configuration of this oxygen atom is 2, 2, 6. And for this one will be 2, 2, 6. And for this one is also 2, 2, 6. These oxygen atoms are supposed to gain electrons each. This one needs the 2 electrons. This one also needs the 2 electrons. This one also needs the 2 electrons for them to be stable in their structure. And where are the 2 electrons for each coming from? It is going to come from the outermost electrons for carbon. So it means that there are 4 electrons only and there are 3 atoms of oxygen. Therefore, each one here will take 2 electrons. This oxygen atom takes 2 electrons from carbon. Also, this oxygen takes 2 electrons from carbon. Now, 2 plus 2 makes the total of 4 electrons. So it means that carbon has already used the 4 electrons from its outermost shell. So this one has not gained any, but it needed to have 2 electrons. So the 2 electrons which is missing for this atom makes the radical to be having a valency of 2 in this formula. So here valency is 2 with the formula CO3 and then 2 minus. It is 2 minus because these oxygen atoms are the one are gaining electrons. This is carbonate. This is the sulfate. And sulfate has sulfur and the oxygen. How many oxygen atoms are there? There are 4. So we have the structure here. This is the oxygen. This is also oxygen. This is oxygen. And this is also oxygen. So what is the electronic configuration for sulfur? It is 2 to 8 to 6. Electronic configuration for oxygen atoms, it is 2 to 6. This one also 2 to 6. This one also 2 to 6. And this one also 2 to 6. Then these atoms are supposed to gain electron, and each one will come from sulfur. Each 2 electrons for each oxygen atom will come from the 6 electrons in the outermost of sulfur. Meaning 2 electrons out of 6, you are left with a balance of 4. Another 2 will come here. That is it. Now 4 electrons taken away from this. Another 2 goes there, which is now making 2 plus 2 plus 2, a total of 6 electrons, which are fully used from sulfur. Then there is the 2 which is needed here, but this 2 is not there. So the 2 which is needed here on this, it is the one that makes the valency of sulfate to be 2, giving it a formula of SO4 minus. Nitrate has 1 nitrogen atom and then 3 oxygen atom. So the structure is the NO. Electronic configuration is 2 to 5. This one is 2 to 6, 2 to 6, 2 to 6. So how many electrons here? There are 5. So this one will take 2 electrons to make this one 2 to 8. This one also takes 2 electrons from nitrogen. So the total is now 2 plus 2, giving 4. This one is supposed to take also 2 electrons, but it has taken only 1 because of this 2 plus 2 making 4 electrons. And out of 5, you remain with only 1. So that 1 electron goes here. There is this oxygen needs the 2 electrons. So there is a balance of 1 electron which is remaining, making 1 valency, which is the minus, and is on the oxygen atoms in the radical of nitrate. Let's look at the radical of this category. Hydrogen carbonate. What is the valency of hydrogen carbonate? Already, hydrogen has valency 1, and the carbonate has valency of 2. This one has valence of 1. So, what is going to be the valency of hydrogen carbonate radical? It will be 1 minus 2, giving it a valency of 1. And therefore, this is the formula of the ion. That is hydrogen carbonate. Then hydrogen sulfate still, this one has valency 1, and then the whole of this sulfate has a valence of 2. So the valency of hydrogen sulfate will be 1 minus 2. So the valency is 1, and giving hydrogen sulfate with the 1 minus. Then dihydrogen phosphate this one has the hydrogen only has valence of 1, but there are 2 atoms here, so that means it is going to be 1 plus 1 minus 3. So the valency will also be 1, making the valency to be 1, and the formula of dihydrogen phosphate ion will be that.